There are two types of stars in the universe, high mass and low mass stars. The difference in between the high mass and low mass stars are the sizes of the stars themselves. Anything above 8 solar masses is a high mass star, anything below 8 solar masses is a low mass star. All stars start out as a protostar. What makes a high mass star different is that it turns into a blue main sequence star, in that it's bigger, it's hotter, it goes through hydrogen quicker. In the death of a star, the blue main sequence star runs out of hydrogen. As this happens, the core heats up and shrinks. This leads to a hydrogen shell beginning to burn around the rest of the now inert helium core. This causes a star to expand into a red supergiant. Shortly after this, helium fusion begins when the core temperature becomes hot enough to fuse helium into carbon. The core then expands, slowing the rate of hydrogen and allowing the outer layers to shrink back down. Once the carbon is out, though, a multiple shell burning supergiant occurs, where the star is now burning through things like oxygen and silicon. As this happens, eventually it hits iron. It can't fuse iron. This causes a supernova, and this is when degeneracy pressure can no longer support the star. The core collapses, leading to a catastrophic explosion of the star. The last step of the death of a high mass star is either a neutron star or a black hole. A neutron star is very small and dense. A black hole is, in essence, a rip in the space-time that leads to heavy gravitational forces affecting everything around it.
Second type of star in the universe is a low mass star. The death of a low mass star consists of 7 basic steps. The first step is a protostar. A star system forms when a cloud of interstellar gas collapses under gravity. The second step is a yellow main sequence. In the core of a low mass star, 4 hydrogen nuclei fuse into a single helium nucleus by the series of the reactions known as proton-proton chain. The third step is a red giant star. After the core hydrogen is exhausted, the core shrinks and heats. Hydrogen shell burning begins around the inert helium core, causing the star to expand into a red giant. The fourth step is a helium burning star. Helium fusion begins when the core becomes hot enough to fuse helium into carbon. The core then expands, slowing the rate of hydrogen shell burning and allowing the star's outer layers to shrink. The fifth step is a double shell burning red giant. Helium shell burning begins around the inert carbon core after the core helium is exhausted. The star then enters its second red giant phase with fusion in the hydrogen shell and helium shell. The sixth step is a planetary nebulae. The dying star expels its outer layers in the planetary nebulae, leaving behind the exposed inert core. Lastly, a white dwarf is left behind. It is the inert core of a low mass star that slowly gets dimmer before completely burning out.